So now we are going to move on from our Kubernetes install, and we're going to move on to deploying VNF Asterisk itself. So earlier I gave a demo of this already running live, and now we're going to go through the steps to actually get it running. And something that you may ask yourself as we go through this, it's why are some of these steps manual? And they're really, I broke out the demo in such a way to show you some of the moving parts. So you could definitely go ahead and go in there and automate all of these steps. But I'm going to show you it piece by piece so that you could get your hands on it and see kind of how I've organized these pieces here, especially with the controller. So, you know, one of these ideas was to have these asterisk instances come up in sort of a generic way, and then move on to the point where you're going to push the configurations into those instances. So what are we going to look at in detail here? I'm going to try to move a little bit swiftly through the slides, but I wanted to show you guys a little bit about how the container images themselves are created. We're going to look at Kubernetes resource definitions, which are kind of a YAML. In this case, we're using YAML to specify how the pods are going to be created, how the persistent volume claims are laid out. Then we're going to run the deployment itself, and seeing that this is also a danger demo, we may have to troubleshoot it. Looking good this morning, so I'm feeling pretty good about it.
So far we haven't troubleshooted too much stuff. So
yeah, so that's not too bad.
Troubleshot.
So let's take a look at the Docker images. As I mentioned a little bit earlier, all of these images are available publicly, and the Docker files to create those images are also available publicly. So a Docker file is how you specify what pieces are going to appear to be on disk to those processes running in containers. So we've got the VNF Asterisk controller, which is sort of the tooling around Asterisk that makes it VNF Asterisk. Docker Asterisk, which is a project of mine that's been around for a while, are Docker files to run Asterisk. And then I also contribute to the Homer project and to their Homer Docker project itself. So if you take a look at a Docker file, some of the things that you're going to notice in there is that basically it's a bunch of bash commands in short, but it's always from a base image. So you say this is from CentOS, for example, and typically someone else has created this base image for your convenience, and you say, okay, I've got CentOS. You could, if you wanted to get really detailed about it, you could use something like a disk image builder, and you could build your own base images. For the most part, that's unnecessary to do. The CentOS maintainers maintain these CentOS base images for you. They're very convenient to use. You can also set environment variables in here that you may use to figure out some metadata about your images themselves. And also then you run commands. So for example, each of these lines that are prefixed with run, you're going to see that there's some packages being installed. There's a git clone happening here. So this is an example from my Docker Asterisk project. Something I wanted to note with all this talk about Docker, as Leif mentioned earlier, so only gloss over it, is that I highly recommend Docker if you're new to containers, and there's lots of great community support out there, but there's also other things on the horizon, especially the Open Container Initiative and the other runtimes that are available, and maybe the wave of the future. let's take a look at the Kubernetes resource definitions themselves. These resource definitions are going to define, especially in this case, the pods that we're going to run. And I just wanted to go over, again, quickly, what is a pod. And so pods are logically grouped containers. They are containers that are going to share things between them. So those things that they may share are network interfaces and volumes, for example. So in this example, I show that there's asterisk and there's a capped agent. Somebody pointed out in one of my earlier sessions, why didn't I just use hep.conf instead of the capture agent? Well, I specifically did this for the example of showing a couple like containers here. You certainly could use hep.conf instead. So in order to specify that, we would use a what I'd colloquially call a pod spec. So all of these YAML files that you feed into Kubernetes to create these resources are technically a resource definition or a Kubernetes object definition. Is that about right?
Yes.
Okay. And but colloquially, you'll hear them referred to as a pod spec. And basically, it's some YAML that's telling the Kubernetes API, this is how I want this pod to be created. So in this example here, we're saying that the type of resource this is a pod. And there's kind of some remixes of that I'll get into in a second. And then we're going to say which Docker container image to run. And then we're going to say, here's a volume to mount. So that could be your persistent volume, for example. And then also here, I've got a config map. I think I'd take a look at that in a further slide. So one of the kind of remixes of the idea of a pod is a deployment and a replica set. This is something that we can use to scale those pods. So when I create a deployment, I can say I need n number of instances. And what it's going to do is create a replica set. So the deployment abstracts the replica set, which then creates multiple pods. When I get into the demo, you're going to see me spin up a deployment, but then I'm going to scale it up so that I don't just have one instance of asterisk. I'm going to create a second instance of it so that I can make a call between the two of them. And I do that with a deployment. And it's just a way to say, I have a pod, but I really need like better control of the scale of the pods that I have. If you were looking at this deployment here, you would see that it's kind of deeper into the deployment definition is the pod spec itself. So that bottom line there, spec, the whole pod spec as before, that's like the pod spec we were looking at a couple slides ago. And it's kind of a template here. So it says going up here, template is what we're going to replicate. And above that is the number of actual replicas that we have. And we're saying that the kind this time is not a pod, but a deployment, which is really just an abstraction of your pods proper. I also have in here config maps. And config maps are a way that I can inject configurations into these pods. In this particular case, these are mostly static configurations. So there was a few things in here that don't necessarily need to have the configuration pushed to them proper. For example, I wanted CSV CDRs, so I injected a cdr.conf into each of these. And my pjsip.conf is really simple in this case. And as we mentioned earlier, we use sorcery to really push all the configuration to these guys. But I know that I needed to specify a transport every time. So I just put it right into that config. So there are some config files packed into a YAML, and you say, hey, this is where I want to mount it, this is where I want the file to appear. All right, so we are going to move on to the demo. Let's go ahead here. All right, so I went to list pods and I don't have any, which is good. That's right where I want to be. And I can show you that I've got the same nodes as Life showed earlier with the cube master and then the 3 nodes in particular. What I'm going to do now is I am going to create, given the pod specs that are here, I've already cloned Git repo here, and if I list here, I've got 2 YAML files. So let's take a look at this pod spec, which is going to have in here some configuration maps, a deployment for Asterisk, etc. I won't belabor this one. You can take a look at it later. But I can say Kubernetes create from a file and Homer. So I've got both VNF Asterisk and Homer itself. And we'll let it go and create all of the pieces in there. And we will watch it come up. All right, that will take just a moment for it to come together. Any questions so far? All right, in the upcoming steps, what we're going to be doing is we're going to do just a little bit of setups to kind of groom some of the services that have been created here so that we can access the web UI for the visibility of the discovered Asterisk instances. And we will then interact with the VNF Asterisk controller itself, which we are going to use to dynamically create a trunk between these 2 Asterisk instances that we'll bring up. So wait for this to come up. Then I'm going to scale up that Asterisk instance, and we will bring it from there. The only thing that we're really waiting on right now is we're waiting for some images to be pulled to each of these nodes. So I had run the demo against this cluster a couple of times, but because the pods are going to arbitrarily wind up on these nodes, not all of the images are available there yet. And so it's going to go and pull those. And as I mentioned before, it's pulling them from a public repository. In a production situation, you'd pull from a local registry. So this would happen much more quickly. And it looks like we're getting there. We've got just a few things to go. Okay, I have got all of these pods running. All right. One of the first things I'm going to do here, and this is really just a little bit of housekeeping, is I'm going to grab the IP address of the master and then create a couple services that are exposed to the outside world. We have this set up in a couple different ways so that you could use either bridge networking or NATed networking for your virtual machines. And in this particular case, I just need to set it up to tell it I'm using the bridge networking. So here I'm exposing some services. This will let me access them from outside of the cluster. All right, with that in place, first thing I want to do is test and make sure that, so let me show these services that I created. Each of these services abstract the pod from the actual service that you are requesting. So if I say I want to talk to the VNF controller, I can just talk to a DNS endpoint, and I don't have to worry about where that pod is and what IP address it has. So it provides me some convenience. So I am going to actually query the API that lives at that controller address, and I'm just pulling up a test endpoint to make sure it's healthy and it looks good. So the next thing I'm going to do is see if Asterisk itself will respond to me, just to make sure. And it does. So what I did there was I pulled up the name of the Asterisk pod, and then I just said core show version so I can see that it responds. And I'm happy with that. Now that I am going to just check the IP address of the master, and since I have that, I can now pull up a browser and bring up the web interface. So let's do that. So this is the web interface for the controller, and it will show me that it discovered one Asterisk instance that has been named Cleverelian. Now, I've got one instance of Asterisk, but in this particular case, that's not enough to make a phone call. We're going to spin up another one, and then we'll create a trunk between the two of these instances. So I can find my cursor. It's got to be around here somewhere. All right. So we'll specifically bring up the Asterisk instance. So if I show the deployment for Asterisk, I've got, I desire to have one instance, but I actually now have changed my desire for two. So I'm going to say scale that deployment to 2 replicas. Okay. Oh, yeah. Well, I want to scale the Asterisk deployment. And if I get that deployment again, I can see that there's 2 desired. There's 2 currently. Only 1 is available. So if I go and watch these again, okay. And now we have 2 instances of Asterisk running. Let's take a look here. There was in the demo earlier today. There was 2. Oh, I'm sorry.
Yeah, just a little while ago when it was spinning up pods, it showed 2 deployments.
It showed 2?
Yeah, now it's showing the same guy.
Well, let's scale it down and scale it back up.
Maybe you must have had a number 2 in the deploy file, maybe.
When you showed the VMs that were listed, like the Camilio and that, there was 2 Asterisk. I don't think it was 2 there.
Go back, double check. There's definitely 2 Asterisks.
So this one has been up for 1 minute. This one has been up for 8. So. Oh, so
2 of 2.
Yeah. So 2. Yeah. No. good eye. So what that means there in the ready column is that 2 containers in this pod are ready. So if it said 0 out of 2, that'd mean none of the 2. In this particular pod, there are 2 containers. One is Asterisk, and the other one is
The Homer capture
is
agent.
Homer. Yep. So okay, now that I've got these 2 instances here, what I'm going to do is talk to my controller API again. And in this case, I'm pulling up the discover endpoint, which goes and discovers all the Asterisk instances that are available, as has been reported to etcd that we're using for service discovery. So there's one instance called Clever Alien and another one calling Loving, I can't pronounce it. And if I go and refresh this, we can see that there are these 2 instances that have been discovered. So now I'm going to use this cheaty looking bash script to pull up the UUIDs for each of these. And we'll get the second one here. And then lastly, I'm going to call the connect endpoint of my API, which I'm going to feed into it both UUIDs. So I called the controller, the connect endpoint, and then I passed in both of these UUIDs from here and here. And then it's returned to me some JSON. But what that endpoint does is, behind the scenes, I say connect this Asterisk instance with this second Asterisk instance, and then it's using sorcery to actually go and create those trunks. They're PJSIP trunks. All right, so let's take a look at one of these Asterisk instances. And so here I've just said execute this command in one of the pods, and we're going to do PJSIP show endpoints. So in this particular one, the other endpoint is this pod name. And so we have trunks created in there now. Now that I have that, I should be essentially to the point where we were in the earlier demo, where I can make a call between these. So let's get the pods. I'm going to pick this one here, and I'm going to say cube control, execute this command interactively with a TTY for this pod using the Asterisk container, and I'll run Asterisk itself, and then I'm going to do PJSIP show.
Just to iterate, so the asterisk with the funny extra characters is the pod name, and -c is the container within that pod, since the pod can contain multiple containers. So you have to define where you're passing the command to within that pod.
Thank you. Okay, I can see here's the other side of this one. So I'm going to say, let's go and channel originate. Okay, cool. So the other side answered, and we'll give it a little time there, and then I should be able to.
And it's all brand new, because we can see the channel ID is all zeros. So
Yep.
you're not cheating.
I'm not. Luckily, I'm not cheating. At least not badly. And there's the CDR. Now we also should have a Homer instance available here too, which is going to be. And we'll log in there. Nope, don't want to save any of that. So I'm going to say we'll look at today, and we'll search for this. And at 14:59, that's about right. we have made a call, and we can see the ladder diagram for it here. So that concludes that part of the demo, and happy to open the floor to any questions. Yeah.
Do you know if there's any other like ecosystems that sort of try to do like what you guys are doing? What's your closest competitor to like the infrastructure that got put together?
So questions basically, what is there any other existing ecosystems that basically are doing what we're showing? Does that just for the?
You guys have the market cornered.
well, we're not trying to market anything. We're not trying to productionalize this. This is a gap analysis tool. We're more interested in the underlying layers, the infrastructure itself. We're Asterisk guys, so Asterisk is the low barrier of entry for us, as opposed to using something else. So it's all the Kubernetes and the spinning up and the GlusterFS and the persistent storage and the cloud infrastructure underneath. That's really what we're actually trying to test and trying to understand. And to do that, we're basically creating VNF Asterisk as a workload tool in order to understand where the gaps are when you're trying to run a piece of application that isn't necessarily web-based.
Right. So, if we were router guys, we might use Quagga to do the same thing if that's what made sense to us. So yeah, VNF Asterisk itself isn't a project as much as it is a research tool. Mm-hmm. But on the underlying layers for like container orchestration, Kubernetes isn't the only answer to it. There's definitely other orchestration tools out there, one of which would be Docker Swarm is one that people use.
Mesos?
Mesos is one. I believe that's from the Apache Foundation. There's Rancher. Yep.
Or Rancher, sorry.
So those are some ones to take a look at too for container orchestration.
So you guys are at the point where you're quite stress testing it then? Like not just doing the one call?
Close. So the question basically, are we stress testing it? And that is the intention. The interesting bit for us is to leverage this platform in order to start doing stress testing, load testing, figure out where, again, gap analysis, like what works, what doesn't work. Eventually what we'd like to do is start interacting with, passing it via SRIOV and like doing a test and be like, okay, we get this line rate, what's the gap? Like what's the difference between, if I run SRIOV for under the networking layer or if I just use flannel, what's the percentage difference? What happens when I scale it out to multiple nodes? What happens when I start scaling up lots of containers and then running one channel through it and chaining them versus running, a few containers and then overloading the containers? What's the monitoring? How do I monitor that data? What's the gap? How do I get that information out and present it? And then how do I utilize that data to dynamically scale everything back up and understand how to scale things up and down? And it's all of these types of things within the infrastructure. That's the interesting bit. Asterisk is just such a good tool. One, we have the knowledge because we've used it and come up with that. But Asterisk just in a tool in general is so flexible and is kept up with this kind of this web world or this like API-based systems and the control model and the control data plane models and all of these. It fits so well for what we're trying to do and understand VNFs. That's kind of where we're driving towards. It's less about the application itself and rather about building a workload that's flexible to understand all the underlying infrastructure.
So one thing that I am actively trying to pursue with using this is using it in a continuous integration workflow. So that we create CI tooling, we deploy Asterisk or deploy Kubernetes as we did earlier, and then deploy VNF Asterisk on top of it, but then with varying configurations and scenarios underneath. So for example, a coworker of mine, Tomofumi Hayashi, created a tool called Coco, which is a container connector. and it's for a kind of like isolated networks between containers. And it also has some functionality for some port mirroring using TC, I believe. But I was like, hey, this is like a great way to actually put a workload on Cocoa and spin up Kubernetes with Cocoa, with VNF Asterisk, create a scenario that says, I want to create these Asterisk instances, put a call over it, use a port mirroring to Homer, for example, and then say, okay, hey, let's actually validate this. Let's pull some data out of the MySQL database from Homer and make sure everything's good, and then potentially, regression test Cocoa for when changes are made to it. So that's like another place that we can use it.
And then part of that will be eventually to start consuming it under CI, continuous integration, and be able to test it and be able to do historical comparisons. So, if we're running Kubernetes 1.75 and 1.8.0 comes out, can I run the same test, and is it better or worse? Is there changes I can make to the underlying system to make things better or worse? And understanding, again, it's all about metrics and trying to understand, are things progressing forward, not progressing forward? I mean, the initial CI will just be deploying our Ansible and be like, does it still work? Does it fail down somewhere? Like we ran last night with 1.8.0, they added a new column, and one of the things that we had, the column was offset incorrectly, so the IP address didn't get populated into the template, and just understanding all of that so you're not figuring it out the night before a live demo.
Right, yeah, we really were regretting not having finished our CI work on it.
Getting
at that
close
point.
on it, but
yeah.
How are you grabbing the data that you were feeding Homer? What's running?
how are you grabbing the data that's running that's
and
for Homer?
In that particular case, it's the Homer project called capt agent. It's like capt-agent. There's also, I forget which version it came in at, but there's also a like native HEP module in Asterisk that can feed
12 or 13 maybe?
So HEP is Homer Encapsulation Protocol, yeah. And so then if you compile it with the HEP module, then you can just define in your hep.conf, like here's where my endpoint is. I used capt agent just to make for an example for a pod.
A multi-container pod.
Yeah.
And it's an RTP as well?
And so I believe it can do, RTCP. So that's like the control protocol. So it can collect some RTP metrics from that.
Anything else? All right, we'll call it. We'll be around, so if anyone has any questions or any other things that they want to go through or anything, then that's great. And otherwise, thanks for hanging out with us today.